by Upeka Gunaratna. It's sponsored by 1.5 Design, the TREMS project. It's on advanced manufacturing of prefabricated structural insulated panel systems using sustainable bioproducts and laminates. I know the main principal supervisor here, Dr. Kasun Chanaga, already here. So Upeka. I think that must be. It's not working? No, it's okay. Yeah, yeah. It's for the online audience.
Yeah, good evening, everyone. I know you may be a bit tired by now. Please bear with me for 3 more minutes. So, right. So let's delve into the world of sandwich panels, not the tasty kind that we eat, but the sandwich panels that we use to construct our houses, right? So even though sandwich panels, so please just first imagine these panels as a sandwich with 3 key layers, 2 skins providing structural strength and a core providing insulation. Even though sandwich panels are considered as energy efficient materials, there is an inherent issue with their embodied energy, as Dr. Shanaka mentioned earlier. So the raw materials that are used to construct these panels have a very high carbon footprint. So also these panels are not easily recyclable as well, leading to construction waste. So this is the problem that we are trying to address with this project. So what the solution that we are trying to bring? The solution that we want to bring is to develop a sandwich panels that has a low carbon footprint. So we are trying to do that by developing a sandwich panel with fully bio-based and recyclable materials. So our vision is to craft a skin with a blend of fully bio-based epoxy resins and bio-based fabrics in combined with a core that is either fully recyclable or bio-based. So currently we are mainly focusing on testing skin material. So we have tested skin materials with fully and partially bio-based epoxy resins in combination with bio-based fiber materials. So what I found out is, encouragingly, the fully bio-based resins can be used to construct reliable and strong skin materials. So we also started preliminary testing sandwich panels as well. So a notable advantage that you're seeing is the lower density. The density ranges around 170 to 250 kilograms per meter cube, yet achieving impressive compressive strengths comparable to market competitors. So as our next steps, we are gonna explore other resins and fibers to further refine our skin materials, and also simultaneously we are on the lookout for bio-based and recyclable core materials such as hemp and mycelium. So we are in further steps. We will numerically model these panels and see analyze their behavior. Also, we'll test their fire performance as well. So I explained the problem and the solution. So what's the impact that we want to make with our solution? So we believe that these panels represent a meaningful and efficient solution to reduce the carbon footprint and the construction waste in the building industry, especially within the modular and residential construction sector. So we hope we can make a meaningful and lasting impact in the construction sector. Thank you very much. And I would like to acknowledge our industry partner as well, Less Than 1.5 Design, for their unwavering commitment. Thank you very much.
Thank you. Thank you very much. I think you're tackling an important problem because the tackling SIP panels have been used, so we just can't go on like that. Get into the net zero circular economy. Had to look at the bio-based solutions. So thank you very much for really all your work on with Dr. Kasun Chanaka's leadership and with 1.5 Design help, Less Than 1.5 Design help doing that the new work, groundbreaking work. So any online questions?
One question, have you considered investigating its fire resistance?
Yes, that's a part of the project. So we have not come to that stage as well. Since we are using bio-based product, there will be an issue with fire performance. So we are going to explore that as well in the later stages.
Thank you. And any other questions from the audience? So are you sort of, yeah, maybe first David, yeah. I'm just asking them later on, but I can.
Thank you. will you need to later separate the bioskin to get to the recyclable core, and how will you do that?
Yeah, that is also a good question. That's one area that we are working on. So, like, there are like solutions, like chemical solutions that we are like, not in my PhD, in the overall project that they are trying out, that will kind of separate the core and the skin. So and not only the core and the skin, within the skin as well, there is epoxy resin and the fiber. So they're trying to separate the fiber and the resins as well, so they can reuse and recycle.
Thank you very much. Any other questions?
Is the material combustible? And if it is, are you looking into reducing its flammability?
Yeah, related to the previous question as well. Yeah, we have to test the materials for their flammability. We will be testing, and we will be testing the overall panels as well. If they do not perform well, we have to think of ways to adhere to the guidelines.
That's excellent. So this is the advantage of TREMS. I think you should, both of you, start talking, because all that work you are doing in your radiant panel testing as well, right? You're using. So
radiant panel, but our is not
based in Bandura?
Sorry?
Based in Bandura, is it? Yes.
Yes, Bandura mainly. Yep.
So I think that's, let's give you the mic. But so it's like the, I think you can directly see a link, right?
Yep.
Doing your testing.
We will try to communicate after this.
So that's the advantage. You can clearly see today the interactions, and I see number of postgraduates joining. Jen made this comment as well. We are meeting very good postgraduates for the first time, and to be so bringing all of them together. So again, I think it's excellent project, excellent presentation. We have to cover the bio-base. I know, Elena, you also interested in some of that work. So with less than 1.5 design, with Sarah have been there all day. So excellent presentation. Can we show up the session again? Thank you.